Hello and welcome back to question 11 part 4. So in part 4 it says that after completing the shed, there's actually a hole in the left slanted roof. So somewhere on this left side here there's a hole, okay? And because of this hole, when the sun shines perpendicularly onto this roof, the light ray will actually go through the roof and hit the floor or the ground at a coordinate of 360. Given this information, can you find out what is the coordinates of the hole in the roof? Okay, so I've redrawn this question over here. So let me just quickly explain what my diagram is. Right, this yellow line over here is the plane of the slanted roof. Okay, and I kind of know previously that n1, the normal vector to my slanted roof, is -2, -1, 3. There's a hole somewhere in the roof. Right? Because of that, when the sun shines perpendicular to it, which means my white line, my sunlight over here, has a direction vector that is parallel to my normal vector. Okay, or in fact it's just negative of my normal vector. Okay, and you reach a point 360. With this, I can form an equation of line, right? Vector equation of my sunlight over here, and it has to intersect with the plane over here. And I also have the Cartesian equation or scalar product form of my plane as well, so I can simultaneous equation my way out of this part 4. So first of all, I'm going to let the coordinates of the hole, hole be, say, some alpha, beta, and gamma. Okay, then I can say that 360 plus some constant, maybe I can use a phi of my normal vector, will be equals to alpha, beta, gamma. Yes, okay. And then I can also say that if I take alpha, beta, gamma, okay, so maybe I want to write this down first, so I can say that alpha equals to, let's write this down this way instead. So I can say this is 3 minus 2 phi 6 minus phi and 3 phi is equals to my alpha, beta, gamma, okay, for some phi, right? There's some value of phi that makes this true. Okay, next I'm going to actually take the dot product, because this alpha, beta, gamma, right, is on this plane, which means if I dot it with -2, -1, 3, it should be equals to 2. Okay, so the next thing I'm going to do is I'm going to dot this 3 -2 phi 6 -phi 3 phi, dot it with -2 -1 3. This should be equals to 2, because after all, this hole is on the plane, so any position vector that's on the plane dotted with the normal, it should give me 2. Okay, so then I can expand this out. This will be -6 plus 4 phi minus 6 plus phi plus 9 phi equals to 2. Group all the phi's together. I have 14 phi is equals to 14. So phi is equals to 1. Okay, and that tells me that alpha, beta, gamma, coming back to this one. Okay, let's duplicate this. Alpha, beta, gamma. Right, substituting your phi to be 1. Just be 1 phi 3. Okay, but this is not the final answer, because you're supposed to give the coordinates. Right, so the coordinates are 1, 5, 3. Okay, and that is the answer for part 4. Hope this has been helpful for the entire paper. Let me know what other papers you want me to cover. If not, I most likely would choose another paper for paper 2. So until then, catch you on the flip flop.